In the epic 1980 film Star Wars Episode V, we were first introduced to the fascinating Cloud City floating in the upper atmosphere of the planet Bespin. Clearly science fiction, right? Or perhaps not. Could such a future be closer than any of us ever imagined? Could humanity potentially establish a permanent presence in the dense atmosphere of a planet in our own solar system? How about our closest neighbor Venus? In this episode, we'll explore some of the very real science and engineering that could propel us into the cosmos and help make Homo sapiens a multi-planet species. Let's start with a couple of basic questions. What does it mean to make humanity a multi-planet species? And why do some people believe it is so important? You may have heard SpaceX founder Elon Musk talk extensively about making humanity a multi-planet species by establishing a colony on the surface of Mars. His rationale is that, in order to ensure the preservation of our species, Homo sapiens need a Plan B in case something catastrophic happens to Earth and makes it uninhabitable. This could be a natural phenomenon like an asteroid strike or a self-created act like a nuclear war. While Musk has been accused of being overly fatalistic, he is not alone in his thinking. Of course, there are others who agree with him on the long-term vision of humans as a multi-planet species, but disagree on his rationale, destination, or timeline. There are a variety of reasons that different people have given for this ultimate goal. Some agree with Musk's fear leading to his desire for a Plan B. Some believe that exploration and curiosity are merely part of our species' DNA, and leaving planet Earth is simply something that we are genetically programmed to do eventually. Others believe that there are economic, political, or military opportunities that will drive our expansion into the solar system. And there are still others who believe that establishing a presence on other planets may be one of the best ways to help preserve our precious homeworld. But what exactly does it mean to make humanity a multi-planet species? Is it enough to send some short-term exploration missions to another celestial body, like the United States did with its Apollo program? How about a semi-permanent presence in space, like the International Space Station, China's Tiangong orbital station, or any of the several planned private space stations? How about establishing a more permanent presence on the Moon, like the current plans for the American-led Artemis program, or the China and Russia-led International Lunar Research Station? Does being in Earth's orbit or being on the Moon even count as multi-planet? Is that sufficient to qualify us as a multi-planet species? What would that presence have to look like before we can safely agree that we achieved this goal? Unfortunately, there is no clear consensus on the answers to these questions. This is probably due to there being no clear consensus on why we should aspire to these lofty ambitions in the first place. However, there seem to be two obvious parameters: permanence and autonomy. Regardless of what drives someone to think humanity should become a multi-planet species, it seems like there is a need for some level of permanence. A temporary or short-term mission likely wouldn't qualify. A permanent physical structure that houses temporary human crews may be sufficient, such as the orbiting space stations or the planned lunar bases, both of which are loosely modeled on the research stations in Antarctica. But of course, the ultimate state of permanence would be a multi-generational community of people who are born, who live, and who die somewhere other than Earth. They have children on faraway planets and raise families, many of whom may even never visit their ancestors' homeworld. That would clearly be a permanent presence on another planet. So what about autonomy? Arguably, humanity can achieve a state of permanence and still not be a multi-planet species if it continues to rely on Earth resources for its survival. For example, a permanent community on the surface of Mars that could not grow its own food or build its own products would be devastated if anything ever happened to its connection to Earth. This is why most people would not consider orbiting stations or even lunar bases as making humanity a multi-planet species, since their proximity to Earth would never result in full autonomy. For humanity to be a truly multi-planet species, a permanent community would likely also have to be completely self-sufficient. So what makes Venus such a potentially viable destination for humanity? In a word, gravity. Gravity seems to be related to a body's size and mass. Without getting into too much scientific detail, the value of the gravitational pull that humans experience on Earth is generally labelled as 1g. The Moon and Mars are much smaller than Earth, so the gravity on the Moon is 0.16 g, or 16% of Earth's gravity, and on Mars it is 0.38 g, or 38% of Earth's gravity. However, since Venus is roughly the same size and mass as Earth, gravity there is 0.98 g, or 98% of Earth's gravity. This is important for two reasons. First, gravity is the only environmental factor that cannot be overcome by engineering. Solutions can be devised for overcoming all of the other risks humans will encounter when leaving Earth, including solar radiation, temperature fluctuations, high and low pressure, and lack of breathable air, drinkable water, or consumable food. But gravity is different. Yes, artificial gravity is theoretically possible in space by rotating large structures and creating centrifugal force. However, on a surface like the Moon or Mars, humans will have to accept whatever gravity exists. The second reason that gravity is important has to do with making babies. If one hallmark of a multi-planet species is long-term multi-generational permanence, then Homo sapiens will have to reproduce somewhere other than Earth. However, as of right now, it is not known if humans can do this in less than 1g of gravity. It is unclear if humans can conceive, carry a fetus to term, deliver a baby with no birth defects, or if that baby can grow into adulthood and reproduce themselves to continue the cycle. Hopefully this will, in fact, be physiologically possible, or hopefully medical science will provide adequate solutions. But if not, then it is conceivable that humanity may never achieve the multi-generational permanence required to become a true multi-planet species. But what about Venus and its Earth-like gravity? For the past few decades, proponents of human spaceflight have steered away from Venus and instead focused on Mars, in large part because it will likely be impossible for humans to ever land on the Venusian surface. Its dense atmosphere creates pressure equivalent to diving 1,000 meters underwater and temperature hot enough to melt lead. While a crewed spacecraft could potentially reach the surface, no human could survive there for more than a few seconds. In fact, the longest any robotic lander has ever lasted was roughly 2 hours. However, there appears to be a narrow band in the atmosphere at an altitude of about 50 to 60 kilometers, where the pressure is roughly the same as sea level here on Earth, and the temperature is approximately 25 to 50 degrees Celsius, which is certainly hot but not immediately fatal. Additionally, the remaining atmosphere above this layer may provide sufficient protection from solar and interstellar radiation, despite Venus being closer to the Sun and not having a magnetic field. In many ways, these could be the most Earth-like conditions anywhere in the solar system. Even better, Venus is the planet closest to Earth, and its orbit is similar to Earth's. So there are multiple launch windows, and the transit times are much shorter than going to Mars. This means that missions between Earth and Venus can be relatively safer, since astronauts would spend less time exposed to radiation during the interplanetary transit. Of course, there are two major environmental risks to human survival. The atmosphere is primarily carbon dioxide, and the planet is completely covered in a cloud layer of sulfuric acid. Then again, there are already engineering solutions to both problems here on Earth, so it would not require new innovations or technological breakthroughs. only finding ways to scale these solutions and transition them to Venus. For all of these reasons, Venus may end up being one of the most viable potential destinations to make humanity a multi-planet species. So the question becomes, how realistic is it to establish a floating city in Venus's atmosphere? Surprisingly, it might be more achievable than many people think. In 2015, NASA published a study called the High Altitude Venus Operational Concept, or HAVOC, that proposed a phased approach to creating a permanent human presence in the Venusian atmosphere aboard a series of floating research stations. The science and engineering appeared to withstand rigorous scrutiny and helped spawn an upswell of global activity along that technology roadmap. Since then, numerous government agencies, non-profit organizations, academic institutions, research groups, and private companies have made significant progress in a variety of disciplines that could create exactly the future that the NASA HAVOC study envisioned. These include planetary science, interplanetary transportation and communications, human life support systems and food production, solar radiation shielding, space solar power, in-space manufacturing, and of course stratospheric habitats. Humanity will still require an impetus to coordinate all of this into a cohesive effort for Venus, but the building blocks are clearly coming together at an accelerating pace. We hope you have enjoyed this brief glimpse into the possible near future of humans living in the Venusian atmosphere. In other videos, we will explore in much greater detail the many aspects of this grand undertaking. After all, making humanity a multi-planet species on Venus may be something that happens from Earth in our children's lifetime, and not a long time ago in a galaxy far, far away.